This section is called Trend Explorer Overview. So the Trend Explorer is a separate model from the short-term forecaster model, and it is something that is not necessary for creating forecasts. And in fact, you might never even choose to use it or might never need to use it. But it is a good tool for looking into forecasts in more detail than is possible within the short-term forecaster model. So the Trend Explorer is a tool for evaluating and comparing different trending methods or techniques. And so there are 31 trending methods inside the Trend Explorer. And if there's a particularly troublesome data set that you're trying to forecast that you're having problems with, you can copy it into the Trend Explorer and then look at the trend using any one of those 31 different trending techniques. In addition, there is an ability within the Trend Explorer to look at all of those 31 methods at the same time and then see which one of them has the lowest error so that you can see which one of them is working best. So you can use the Trend Explorer in either way to look at a trend in more detail, to calculate and manipulate single trends, or to compare all 31 different trending methods at the same time. So in terms of exponential smoothing, that's actually one of the most important methods within the tool. We have a family of methods. And so if you look on the left-hand side at trend type, we have none, which means you get a flat line. There's no slope at all. Additive, you get a linear slope, a linear line. And then multiplicative, depending on whether it's going up or down, it can go up at an increasing rate or go down at an increasing rate. And then across the top, if you look at seasonality, we have none, additive, and multiplicative. So none means that there's no seasonality. There's no, winter is higher than summer or whatever. There's a fall pattern. So basically every month is kind of considered the same. If you have additive or multiplicative, then you can have a period, add on top of your trend some seasonal periods. And you can look at this graph to see what the additive and multiplicative give you. On the next slide, we have an example of a damped Holt exponential smoothing trend. And on the left-hand side, we've got the historical data with the solid blue line. And then we have the trend with the solid red line, and you'll notice it kind of flattens out as we go, so it's being damped. And then at the high end, we've got the green line, and at the low end, we've got the orange line. Those are the 80% prediction intervals, and the 80% band is user settable, and what it means is that 80% of the time, the results will be within the orange and the green line. Or conversely, 10% of the time they'll be above the green line, and 10% of the time they'll be below the orange line. Here's an example of a Box-Jenkins ARIMA model with some pretty noisy historical data, the blue line. And then what we get is just a flat trend with a prediction interval around it. And here we have a 95% prediction interval, which means that 95% of the time the answer should be within the green and the orange line. 2.5% of the time it's above the green line, it'll be above the green line, and 2.5% of the time it'll be below the orange line. So these two graphs we're looking at a particular data set in great detail. This next table is showing the second type of function methodology that the Trend Explorer has, which is comparing outputs from all the trending types. And what we do here is we actually hold out data. So we have actual historical data that we hold out and we don't show it to the trending methods. And then they trend, and then we compare their trend versus what we held out to see how close it is. and we can look at it for a number of different statistics, the mean absolute percentage error, the mean squared error, etc. And in the model, I don't know if you can see those little red triangles in the model. If you hold your cursor above those cells, it'll give you much more detail on those. So in this case, the multiplicative exponential smoothing, the one at the top, actually came out best on all of the metrics. So it's shown in yellow there, where all the other ones are shown in green. And there's a whole bunch of methods below there that were just cut off. Just for the graphic to show you. So if you wanted to use the best method in this for that particular data set, you'd use the multiplicative exponential smoothing. And if somebody asked you why are you using that method, you could go back to the Trend Explorer and say, well, it had the lowest MAPE, it had the lowest MSE, etc. And here is a graphical representation of that same result. So we have the historical data with the blue line on the left, and then we have the 5 best, we have the holdout sample, which is the solid light green line, and then we have the 5 best forecasting methods, and they're all kind of grouped around the holdout sample, except that most of them are a little bit below it in the final months. But the point here is that you can see which method is working best and actually view that graphically. Well, that's it for this tutorial. Thank you.